So see this problem and try to solve this problem. Check this problem. Please look into the problem. Whether you can able to solve it or not, check it out. If you're okay with it, we'll go. You'll solve it later, or you're okay with it, we'll go with the next problem. Just 2 minutes time I'll give you. You can just please go through it. You try to solve it. At least one you try to solve it and check the answer. Once you got the answer, you please tell me. Okay, got it. They're asking to find where there is no head, there is one head, two heads, and so on. So no head means 0, one head means 1, two head means 2. So we should find x of 0, x of 1, and so on. X of 0, we got something here. X of 1, we got it here. Correct? X of 2, we are solving it. X of 3, we are solving it. X of 4, that's all. We're asking that much only. Right? So 0, 2, 3, 4, and so on, like that they're asking. What is that values you have to solve for? 0, 1, 2, 3, 4. So we solve for 0, we solve for 1, same formula. We solve for 2, 3, and 4. The key of this concept is understanding the question. Answers are very simple. Right? Understand the question carefully. That's the trickiest part. So that if you're clear, then you can easily solve these problems. Similarly, you can go through this problem later. Okay, all are similar type of problem. Right. So next is Poisson distribution. The next is what? The Poisson distribution we have, and here also we have seen in the previous class how this Poisson distribution is working and what are the properties of that and all. And you see examples of this. Example of Poisson distribution. The number of telephone calls arriving at a switching center during various intervals of time. Nowadays, we don't have switching centers. Before, when you are trying to call someone, right, you need to book a trunk call. You know, trunk call you have here. You call someone and tell them that you connect to them. They'll call, connect it, and they'll connect both of you. You know that? You heard about trunk call? So before they are doing that manually, nowadays what is happening, the system itself is taking care of that. No need to do anything manually. So we are able to connect anywhere in the globe within seconds. That is the example. Next one, the number of customers entering a bank during various intervals of time. So we want to find out, okay, during 4 o'clock to 5 o'clock, how many of them are coming? In the morning, 9 o'clock to 10 o'clock, how many of them are coming? So all that you can do by using Poisson distribution. And failure of machine in a month. You try to buy a machine or try to buy a a printer or whatever a machine you try to buy. So what is the probability of that? Within 1 month it will fail means what? What is the credibility of the brand? That we are trying to find. We can do it. And find the number of typing errors in a page. So all these examples will come under your Poisson distribution. Let us see this one here. Let x be the random variable of Poisson distribution with parameter lambda equals to 4 and find the value of x value greater than 2. So lambda value and x value are two things we require here. So lambda is 4, x value is 2. So from that, how to do it? Let us see the problem here. If you want to find this, e power minus lambda, lambda power k, k factorial. If you represent here r, it will become r. E power lambda, lambda power r, r factorial. Whatever you write here, right, that variable you should use. Okay. Now let us see that. So we are trying to find the value greater than 2. Greater than 2 means what? We can, it's like 1 minus x value less than equals to, if you find, we can get the value of greater than 2. So we are trying to find this probability. Less than equals to 2, we are trying to find. Okay. So less than equals to 2 means what? So what is the value of this 2? Let us substitute this the formula. E power minus lambda summation of k to n lambda power k by k factorial. So lambda value is what? 4, we know it here from this. E power lambda, we substitute till here, there is no problem. K value is 0 to n value is what? N value is 2, maximum is 2, let us understand 2 here. We are trying to find for n value is 2. Lambda power k, lambda is 4 and power k. K value is what? K value. K value is 0, 1, 2, like the three values. K value can be 0, K value can be 1, K value can be 2. For example, for this example, if K value is 0, 4 power 0 by 4, 0 factorial. 4 power 0 is what? Anything power 0, it is 1. Something we wrote here 0. 0 factorial is 1. Okay, don't think 0 factorial is 0 into 1. 0, 0 factorial is 1. Next, k value, if we expand the summation, k value is 1. 4 power 1, 4 by 1, 4 we get. K value is 2 in the summation. 4 power 2, 4 square, 16. 16 by 2, 8, we get 8 here. E power minus lambda is e power minus 4 into 1 plus 4 plus 8, we get around 0.238. Now, if you want to find the greater value of that, you subtract from the lesser value. So 1 minus this, you are going to get 0.762. Okay. Why? Because we may ask, sir, why can't we solve it directly? Because we don't know the lower limit or whatever the higher upper limit, we don't know. So greater than, if you want to find, we know here the value starts from 0. So 0 to 2, if you find, remaining value will be greater than 2. Because greater than 2, again, we don't know where it will end. We cannot take the end value. Right? For this one, we cannot take the end value. End value can be 3 only. End value can be 4 or 5, 6. We don't know. It's unpredictable. So the best is we can able to solve in this way. Easy way to solve it. Smart way to solve it. Okay. Next problem. Let x be a Poisson distribution such that p of 1 equals to p of 2. Find p of 4. What is this p of 1, p of 2? What is p of 4? Let us see. Right. So this one. We know that this is the formula for the Poisson distribution. And we told p of 1 equals to p of 2. Correct? P of 1 equals to p of 2 we wrote here. And what is this p of 1? Lambda power 1 and lambda power 2. Same. Instead of 1 we wrote 2. Like this we wrote it here. Then, so e power lambda, both the sides we have common. So we have striken that. And lambda power 1 is lambda. Lambda power 2 is lambda square. Lambda by 1 equals to lambda square by 2. So multiply, cross multiply that. So lambda square equals to 2 lambda. So lambda equals to 2. We get from this lambda equals to. How we get it? Lambda equals to 2. How we get this lambda equals to 2? If you know how to do, how we get lambda equals to 2, you substitute that for 4. P of x equals to 4, you substitute the value of that as 2 here. Lambda value is 2. So based on that, you got this. Okay. Similarly, next problem, the Poisson distribution. To find the probability for 0 to 5, so you should know the 0, should know 1, 2, 3, 4 and 5, both inclusive, 0 and 5, because equals to is there. Okay, so from that formula you will subtract or summate that. So lambda value is 4, we know it, and power k value is varying from 0 to 5, so 0, 1, 2, 3, 4 and 5, and corresponding factorial is given down. To expand that, if you solve that properly, you're going to get this answer. Okay, fine. So this example you can go through. Example 4, you please go through on Poisson distribution. So with this, we have seen all the examples from distributions. Yeah, let us come to the checkbox. Take a pen and paper. We need to solve problems on Bernoulli distribution. What is the definition, equations, and example problem on Bernoulli, binomial, and Poisson distribution. What all three? Bernoulli, then binomial, and Poisson distribution. Still more problems are there, you can go through them. Still all these are that problems on Poisson distribution. Any problem you feel difficult, you tell me the page number, I will discuss that. Okay. So next is what? So we have seen the PDF, right? So PDF for continuous random variable. Till now we have seen for discrete random variable. Now continuous random variable we have found. Properties of continuous random variable. What are the properties and examples of continuous random variable? For continuous we have examples what? Uniform, exponential, Gaussian. Uniform, exponential and Gaussian distribution. So let us see something on uniform and Gaussian distribution. So this is how to find a CDF, right? How to find the CDF is what given here. Examples of that. How do you find the cumulative distribution function and exponential? All mixed up problems are there in this. Go through this problem and yeah, continuous random this variable we discussed here. So we are going above or we have come down. Sorry. Continuous uniform distribution. We have seen continuous distribution from A to B. It is continuous, same value for the f of x. Okay, and how to find PDF of continuous distribution, uniform, PDF and CDF. How to find the PDF and CDF. The proofs are given here. How to find the PDF value and CDF value, and the proof for variance and mean value is given. So you can find that these problems we have discussed already. You can go through this problem and find the mean, variance and standard deviation along with the probability of the problems, uniform distribution. So you should write down there. Next is uniform distribution, explanation and mathematical equations of CDF or PDF, mean, variance, standard deviation, all three, and the corresponding numerical problem from it. Next checkbox. All the problems are from uniform distribution. We have discussed already uniform distribution problems. So next is exponential distribution. Exponential distribution, we have to see the same again. What is the distribution for PDF and CDF? What is the mean, variance, and standard deviation proofs? And one example. Are you understanding it? For continuous distributions, we have the proof here. Form. What is the proof? Explanation, mean, variance, standard deviation. Similarly, exponential distribution, explanation, proof, mean, variance, standard deviation. One example for this exponential. And last one is what? Gaussian distribution. That's what we have discussed. Gaussian distribution. Again, explanation of this, mathematical equations, right? Mean, variance, standard deviation, properties, and one example on this. Okay, you'll get one table like this. I will show you. So when you have any problems on this distribution, right, you'll have one table like this. This table will be given for you to use. To show you that all these problems are on the uniform distribution. Show you that, and some problems are there here on mean, variance, and standard deviation for discrete random variables. Mean values, variance, and standard deviation values are given here. You can go through this. I'll show you the table. Last page we have. Yeah, this table we're going to get like this. So negative area, okay, the normal curve and the positive area. I told you already, if you want to find 0.25, how do you find 0.2 here and 0.5 here? 0.25, if you want to find, the correspondingly should come in this line and you should end up with this point, 0.5, this value. If you want to write 5.7, 0.57 if you want to find the distribution, 0.5 and 7, 0.57. If you want to do 1.4 distribution, so 0.1 and 0.4 here. So like that you should see the distribution. Similarly, you can go up to 2.7 if you want to find 2 here, 2.7. So 0, 1, 2, 3, 4, 5, 6, 7. So this is what the 2.7 distribution. Okay. And there are various other problems here. When you find time, you do it. So as of now, each one example problem is enough. And finally, what you should do is, you should take a piece of paper and pen, one A4 sheet, write all the distributions and all the formulas. Let us say take 4 or 5 columns and rows. Each row you write binomial distribution. What is the mathematical expression for it? What is formula for mean? What is formula for variance? What is standard deviation? How to do CDF? How to do PDF? Like that, you should be able to do it by end of this. After studying first module, you should be able to remember all these formulas. Then you can easily do the numericals. You take a white sheet, A4 sheet, and write all the applications like uniform problems, uniform equations, and then after uniform, exponential, Bernoulli, right, and binomial, Gaussian, Poisson. All these 6 of them should know the formulas on your fingertips. Okay, then you can solve any kind of problem very easily. Fine. Application part is very important, and before that, you should know the formulas of CDF, PDF, PMF, and their properties. So this much if you can learn, you're done with your first module very easily. Now it's up to your discussion to you. Anyone have any queries in particular? Please, you're welcome. You can ask. You're clear with how to study from this class? Yes or no?
Yes, sir.
You comfortable now?
Yes, sir.
Yeah. And one more thing, you can see in MS Teams only. There is some option called files option. I've already told you. If somebody don't know, I am telling you again. There is files option. You can see that files option. Someone can see that now only. Can minimize the screen or see the files option. Correct? You can see files option. Where you can see files option, go to Teams only. In the Teams, you have 4th semester theme, right? 4th A. There, if you go, there are a lot of options. 4th A, posts, files, class note, assignments, like that. I've already given the assignment there. And the file section, if you go, okay, you go to file section. There, one folder will be there, 18EC44 folder. 18EC44 folder. You got that 18EC44 folder? Inside that, you can see assignment questions are there, class notes is there, syllabus is there, model question papers are there. Whichever you want, you can download from that. Everything is uploaded there. That's why I have not posted in your WhatsApp group. You can download from your site whenever, whatever. Correct? You can able to see that. Can someone see it and acknowledge me? Assignments, all three are there in single file. 1, 2, 3. Three modules. Fourth and fifth module will be taken care by mathematics department. Okay. Linear algebra part will be done by them. Assignments are there. I checked it. You also can please see class notes if you go through. Module 1, module 2. Folders are there, right? Hello. Can you able to see that? Yes, no. Hello. Yes. Yes, thank you. If you all able to see that, you can give raise your hand. You all can see the files. From that, you can raise your hand and you can leave the meeting. I can see 8 of them can see that. Thank you. You all see the next class. Thank you. You can leave. See you in the next class. So next class probably will start the second module. Thank you all.
Okay.